Welcome to another episode of Terry's Notes, and today we're going to be looking at the January 2017 paper question 10. Okay, so question 10 part A is a circle geometry question. So we have a circle. The vertices H, K, and L of a quadrilateral lie on the circumference of the circle. PKM is a tangent. So basically the information given here is drawn on the diagram. So they said calculate given reasons for each step in your answer the measure of HKL. Where is HKL? So HKL is this angle here. But how do we get HKL? Now just by looking at this here, I can tell you that HKL is equal to 20 degrees. Why can I say that? The reason is that angles in the same segment are equal, right? So we have this point here, which is H, we have L, and this angle here is 20 degrees. We start at the same point, H, go up to K, and come back to L. So therefore this angle here must be 20 degrees, right? And the reason is angles in the same segment are equal. So angles in the same segment are equal, right? So that's part one. Part 2, they want JOK. Where is JOK? JOK is this angle here. Now OJ is the radius of the circle. OK is also the radius of the circle. So therefore triangle JOK is isosceles. Right? What that means is that this length here is the same as this length. So therefore this angle here must be 50 degrees. Okay? Alright, because in an isosceles triangle, two sides are the same and two angles are the same. So since this side and this side are the same, it means that this angle here, which is 50, is also 50 on this side here. So they want JOK. So therefore, that's this angle here we want to find. So therefore, JOK is equal to, remember when we add up the angles of a triangle, we get 180. So it's 180 minus 50 plus 50, which will give us 180 minus 100, which will equal to 80 degrees. So that is the angle JOK. So we have to use a fact that the triangle JOK is isosceles. So we've worked this out. Now we want JHK. JHK. Where is that? JHK. Right. So JHK is this angle here. Right. How do we do that one? Okay. So HK is a diameter, right, of the circle. Why? Because you are joining, you have H is on the circumference, K is on the circumference, and it passes through the origin or the center of the circle, right? So if we have a diameter, and what we do know is that this angle here, that is HJK, that angle must equal to 90 degrees. Right? That is simply one of the rules. The angle in a semicircle is a right angle. Okay? So this is angle in a semicircle is 90 degrees. Right? So we know that HJK is 90 degrees. So we have a triangle here, HJK, and we know one side is 50, this side here is 50. We know that this here, this whole angle here is 90. So therefore angle JHK is equal to 180 minus the 90 degrees plus 50. And this will give me 180 minus 9 and 5, 14. So this is 140. So therefore JHK is equal to 40 degrees. Okay, so we've worked out all the angles that they've asked us for. Let's move on to the next part. So in this one here, we have a bearing question. So we have a ship travels from Akron, A. So the ship is traveling from here. It's on a bearing of 30 degrees. So therefore we know that 30 degrees should be here, right? Because we're going from A to B, we have to draw a north line at the point A and measure 30 degrees in a clockwise direction. So this is where the 30 degrees is. Then, right, so the ship travels from Akron on a bearing of 30 degrees to Belleville. So we're going here to B, 90 kilometers away. So therefore we know that this here is 90 kilometers. That is the distance from A to B. It then travels to Compton, which is 310 kilometers due east of Akron. So therefore, it is due east. So therefore, this distance here is 310 kilometers. That's from here, A to C. And just remember that C is due east of A. So does that indicate on the diagram the bearing 30 degrees? We've shown that. The distance 90 kilometers and the distance 310 kilometers. So we've done that. Now they want to calculate to the nearest kilometer the distance between B and C. B and C. So they want this distance here. Right. So let's see so we have a triangle here basically. We know that if this is 30 degrees, then this angle here has to be 60 degrees, right? That is from here to here. The triangle is not a right angle triangle, so we know that we either have to use the sine rule or the cosine rule. So let's see, we want to get BC. One second. Okay, so we have two sides and an angle between them. So we have the angle here, which is 60 degrees, and we have the two sides of 90 and 310. So we want to find BC. So I'm going to use the cosine rule to work out BC. So how do we do that? Now, before you even work a question like this, you should write down the formula for using the cosine rule. So C squared is equal to A squared plus B squared minus 2BC cos the angle, which is in this case is big C. Right, so this is just the formula, right, for the cosine rule. Now we have to apply it to the question now. So A and B represents one side. So let's say, so A could be the 90, B could be the 310, and the angle C in this case is 60 degrees. Cool? And the side that we want to find is BC. So we're going to put BC squared is equal to 90 squared plus 310 squared minus, put all of this in brackets for me please, 2 multiplied by 90 multiplied by 310 multiplied by cosine of 60. So BC squared is equal to, now let's do this in parts because some students, they tend to make mistakes here. So the first part, 90 squared will give me 8100. So this is 8100 plus 310 squared. That will give me 96,100. So this is 96100. And we're going to minus 2 multiplied by 90 multiplied by 310 multiplied by cosine of 60. And that gives me 27,900. So this is 27,900. So therefore BC squared is equal to 8100 plus 96,100 minus 27900, which will give me 76300. So therefore BC is equal to the square root of 76300. Therefore BC is equal to 276. They want the answer to the nearest kilometer, so it'll be 276 kilometers. Now let me just use my calculator to double check this here in case I made a mistake. So it's 90 squared plus 310 squared minus 2 by right, so the answer is 276 kilometers. Right, so that's part 2. Then they want to the nearest degree ABC. Where is ABC? ABC. Right, so ABC is this angle here. Right? How do you get that angle? Well, at this point here, we know that BC is 276 kilometers. So this is 276 kilometers. So we have all the sides of the triangle. We have one angle here. We want to get another angle. So we just use the sine rule. So I'm going to set up the sine rule first. I'm just going to put A over sine A is equal to B over sine B. I'm just setting up the equation. I haven't plugged anything as yet. So let's use what are we going to use here? So we can use A as 310. So if we use A as 310 kilometers, angle in this case we are talking about is this angle, which is what we want to find, right? So that is sine ABC. So angle sine ABC is equal to B. So we're looking for a side that we know, and we know the angle. So the side we're going to use in this case is BC. So this will be 276 over sine. What is the angle? So the angle we're looking at in this case here is 60 degrees. Right? So all we need to do is to cross multiply now. So sine ABC is equal to 310 by sine 60 degrees all over 276. So sine ABC is equal to, let's work this out, so 310 multiplied by sine 60 divided by 276, that'll give me 0.973. So therefore ABC is equal to sine inverse of 0.973. So therefore ABC, use our calculator again, and this will be second function sine, and that will give me 76. Well, they want the answer to the nearest degree, so we're going to put 77 degrees. Okay, so in this question here we had to use the cosine rule and the sine rule. Okay, and the last part of the question is that determine the bearing of Compton from Belleville. So the bearing of C from B. So the bearing of C, let's see what they're talking about here. So the bearing of C from B. So this is the point B here, and we want to know the bearing of C from B. So they want to know this angle here. Alright, so what do we know? Okay, so if this angle here is 30 degrees, it means that this angle on this side here is 180 minus 30, which will give me 150. How do I know that? Because this north line and this north line are parallel, right? So therefore, this angle here plus this angle should be equal to 180, right? So this is 150. We just worked out ABC. ABC was 77. So therefore, to get this angle here, right, it'll be 360 degrees minus 150 plus 77, which will give me, let's see what that is. That'll be 360 minus 150 plus 77. That gives me 227. 227. So 360 minus 227. That gives me 133 degrees. So the bearing of C from B is 133 degrees. Okay?